All right, guys. So as I was saying, for the first pair for question 4, we saw that for the numbers, 2 would be the common factor, the HCF, because the highest number that can go into 2 and 4 would be 2. And for the letters, we see that P is common. So our HCF is simply 2P. So pick out 2P. Divide each term by 2P. 2PR divided by 2P. The 2P's cancel, leaving R. We put that in the brackets. Then we have negative 4PS divided by 2P. 2 into 4 goes 2. The P cancels, leaving the S. So we would have 2S in this bracket. So we close our bracket. So move on to the next pair. And then now look for what is common here, which is now Q. So we'll pull out the Q as our common factor for the second pair. We divide QR by Q. Q's cancel, leaving R. Put R in the bracket. Keep on minus sign. So we divide 2QS by Q. Q's cancel, leave 2S. So we put 2S in the bracket and then we close it. So the two brackets have the exact same expression. So we can just treat it as our common factor, our HCF. So the HCF here for the second line would be the bracketed expression. So we have R minus 2S, which is common. So what we do now, we treat that as a common factor. Of course, you're going to divide each of these terms with the R minus 2S. So what we would have now is a 2P in front of that bracket. We will put it in here. And for the second bracket, we would have the plus Q. So we put plus Q in here. And that now would have complete the factorization process. All right. In a similar way, we would do for question 5. I think I can quickly skip question 5, move on to question 6. Now, can anybody tell me how we can approach question 6? Anybody?
Using the distributive law, sir, using what is outside the bracket to multiply what is inside the bracket.
All right, so if we do that though, we're just going to do some redundant work. That means we're going to expand it, then factorize it again. But what is obvious here is the brackets are exactly the same.
Just realize
because the brackets are exactly the same, we can carry on from there, treating these brackets as our common factor. We would pick out the bracketed expression here, which is x squared
plus y squared.
X squared plus y squared as our common factor. And now we open our the other brackets. So of course, if we divide this term by,
sir, on number 5 we are.
I skipped number 5 for obvious reason, because it is the same as question 4. Is that clear?
Yes, sir. Yes, sir.
Yeah, man. Is a similar working to question 4? So once you get the idea of how to work it, you just follow the procedure. So the numbers are different and letters are different, but the procedure is the same. So question 6 is slightly a different setup. So it lays out kind of from, if you look at this, you would actually reach the second stage of the factorization process, because you have the bracketed expressions that are the common factor here. So you just pull out the brackets, which is the common factor. And then now, we are now going to divide all of this by the x squared plus y squared. So that going to cancel out the x squared plus y squared. This will cancel out with this. The A, AB. So we put AB in the bracket. So after you put AB here, then you would divide the next expression by the x squared plus y squared. You're going to be left with minus CD. So you put minus CD. And so we would finish and close the bracket. So that would be completely factorized. And if you notice question 7 is really similar to question 6. So it's the same principle. All right, any question? Can we move on from here? Question 8 is pretty much like the ones before. It's a little tricky still, but I'm going to ask you to do question 8 by yourself. And when next we meet, you can tell me what you get for the answer. All right. So I'm going to now stop sharing this slide so that we can move on to the next slide. All right, so our next slide then has to do with factorizing quadratic expression. Now, when we started off on factorization, I would have stated that there are a number of different techniques that we would apply based on the type of expression that is given. So not all expressions can use the same technique. So we have different techniques for different expressions. So we're going through each expression and showing you the techniques that we use to apply to them. Now for quadratic expression, there are a special form of expression. The general form of a quadratic expression, sorry. All right, the general form of a quadratic expression is of the form of a trinomial. So we say that a trinomial has 3 terms, but what is so special about a quadratic trinomial is that there are 2 variables. So you have the variable x squared and you have the variable x. All right. Now, so the variable x will come 1 with the power 2 and second with the power 1. Now, the last term is actually a constant. When we refer to constant in mathematics, we're talking about a number that remains constant throughout the entire expression. So whenever you rewrite the expression, that number will always occur to be the same. Now, this is a general form of what quadratic looks like. So when we're really working generally, we know that we are using unknowns to represent general quantities. So the A here is the coefficient of the x squared. And remember, the coefficient is simply a number, and we are using A to represent a number for the x squared. The coefficient of x is also another number, but now we're going to use B to represent that number for x. and C is a number by itself. So generally speaking, when we look at a quadratic, it will have this similar form where you have a variable raised to the power 2, the same variable raised to the power 1. You're going to have a number in front of the variable to the power 2, a number in front of the variable to the power 1, and then you're going to have a number by itself. That's a general look for quadratic. So when you see a quadratic, those are the characteristics, or those are the attributes that you look for to tell you that you have a quadratic. And so first, before we try to factorize any expression, we try to identify the type of expression we have. So based on what you're seeing here, you should take these attributes and identify quadratics. Now, these are specific forms of quadratic. This form that we have up here, which is ax squared plus bx plus c, that is the general form. That means all quadratic resemble this. Now, these are specific forms of the quadratic. For the specific forms, it means that you will have a number for A, you will have a number for B, and you will have a number for C. Those are when you have the specific forms. All right, so this here is a specific form, and we can try to identify the number for x squared. For the x squared here, what would be the coefficient? What would be the number in front of the x squared? Anybody?
1.
1. What would be the number in front of the x?
1, sir.
This x here, this one, what would be the number?
5.
It would be not just 5, but -5. And then now, what would be the constant? The constant would be?
7.
Which is a number by itself. So when you really compare this to the general form, the number here in front of the x squared, that we say if there's no obvious number, we use 1. That means for this a would be equal to 1. The number in front of the x here would be -5, meaning b would be equal to -5. And the constant here, which is a number by itself, which is 7, that means c would be equal to 7. Right? So the general form, we just write these numbers as A, B, and C. But the specific forms, we have the actual numbers in them. So for this now, this is another specific form. What would be represented, the A in this form? What would be the number for A here?
3, sir.
Right, and what would be the number for B? Come guys, 2, and what would be C?
-5.
Correct. So for this specific form, the A would be 3. So the A from up the general form here, B, C. So the A in this specific form would be 3. So this would be A. So A would be 3. B would be 2. And C would be -5. So I hope you are able to see how the general form is represented and how the A, B, C are represented in terms of the numbers. And now the variable, for this first one, the variable would be x. And you have x raised to the second power for the first term and x raised to the first power for the second term. For this one, the variable would be a raised to the second power for the first term, and a raised to the first power for the second term. All right, so everybody is clear on the features that a quadratic has. Would you be able to identify a quadratic expression if you see it? Let me see your hand. All right, so what you're really looking for, you're looking for the variables, the x squared, the x, you're looking for the numbers in front of them, and a constant. Now, there might be a little variation of this form, but we are not going to focus on that right now. All we are concerned with is how to factorize these. All right, so to factorize quadratic, we have a special approach. All right, now we have two different approaches based on how the general form appears. So when factorizing a quadratic, you must consider the following cases. Case 1, when the coefficient of x squared is 1. And then when we talk about x squared here, we are referring to the variables in the general form. So the x squared here would be the first variable. So this is the x squared. And this, so x squared, then you have x. Here we have x squared, then we have x. Now this one where we have a, then the coefficient of this one would be a. Now when there's no obvious number in front the x squared, as in this form, then the coefficient would be 1. So that is the case that we are dealing with. We are saying when the coefficient of x squared is 1, meaning when the quadratic is in this form, where there is no obvious number in front of the x squared, then the coefficient is actually 1. Let me see your hands if you understand that, guys. Let me see your hands if you understand what I just said.
You can go over that again, please.
All right. So we have two scenarios for the general form. One, when there's a number that is in front of the x squared, which is obvious, say for instance 2 or 3, those would be numbers greater than 1, right? When the number in front of the x squared is 1, then you don't have an obvious number here. So you're only just going to see the bare x squared right at the front there. But we know that when it is like this, the coefficient, we are going to take 1 to be the coefficient. And if you recall, when any letter or any variables is by themselves, we say that there's an invisible one in front of them that we use as the coefficient. So of the two scenarios, this scenario is saying that in this form, you have an obvious number that is greater than 1, which is referred to as a. Now, in this scenario, there's no obvious number greater than a, so we say that the a is 1. And so this is the first case that we're looking at, when the coefficient of x squared is 1. So we are looking for quadratics where there's no number in front of the x squared. So those are the cases that we are dealing with. So let us deal with that first case. So when the coefficient of x squared is 1, it means that the steps to factorize this is that we are going to be looking for 2 factors of c. That means the last term, remember that the last term is a number, but we are looking for 2 factors, 2 numbers that you can multiply to get c. and the same two numbers that you multiply to get C, when you add them, you get B. All right. So that's the first step in factorizing this case. All right. So after we have found the two factors of C, when we add them, we get B, then we go to the next step. Now, the factors of C, you're going to have to do a trial and error to find those factors. So they're not going to come very straightforward. All right, so after the first step now, all right, so let us work through this question. But the general thing is that what we are doing is looking at the last term. What is the last term here? Or in other words, what is C?
6.
C is 6. So based on this step 1 that we look at, we say that we need to find two factors of 6. But those two factors, two numbers that you multiply to get 6, the same two numbers, when you add them, you get positive 5. What are
1, 3.
Yeah, so that would be 2 and 3. All right. Everybody agrees with that? 2, 3 is 6. 2 plus
Yes, sir, and I know.
give you 5. All right. So once we identify the two factors that we multiply to get 6, so we say 2 times 3. 2 times 3 equal to 6. And we know that 2 plus 3 give you 5. So it means that these two factors satisfy what we're looking for. So that's always what we're doing. We're looking for two numbers that multiply to get C, which is the last term. And the same two numbers, when we add them, we get the coefficient of the middle term, which is the number in front of the X in the middle. All right, now once we identify those two numbers, right, what we are aiming to do, the same two numbers that we add, same two numbers we multiply to get 6, and we add them to get 5, we are going to use those two numbers to replace the middle term. And the reason why we can do that is because there's some give you the same thing as the middle term. So what we do, we take out the middle term, we replace it with a 2x. So we put x beside these, plus 3x. So we take out the middle term, replace it with the two numbers that we're adding to get the middle term. So we will rewrite this now as x squared plus 2x plus 3x and then plus 6. Now, you may wonder why do we do this? All right, now, in a moment, you'll see why this is clear. Why, you'll see clearly why we do this. All right, now, once you have done that, now, what we have created here, we have created a polynomial, which is a 4-term expression. So we are moving from a 3-term expression, which is the quadratic. The quadratic has 3 terms. And now we are converting it to a 4-term expression. When we convert this to a 4-term expression, it means that we can apply factorization by grouping. Because if we look at both pairs, we can identify now common factor for each pair. So for the first pair, the common factor would be x. We pull out the x. So x, pull out the x, open the brackets. Guys, I do wish I could make this thing a little better. All right, so pull out the x. So we say x into x squared give you back just x. And we say x into 2x give you back just 2. Now, so that is our first pair that we factorize. And now we look at the second pair and look for the common factor. Now the common factor here for the second pair is the number 3, because 3 can go into itself and it can go into 6. So we pull out that 3. We factorize by 3. 3 into 3x give you x, because the 3 cancel out, leaving the x. And then now we divide the 6 now by 3. So 6 divided by 3, we get 2. And we close our brackets. Now, as before, the bracketed expression is common, so we just pull it out. And then now, whatever is outside the brackets, we group those and put them into the other brackets. And then you get this. All right, so those would be the factors. Now, so that's the first technique that we will apply when we are looking at case 1 of the quadratic. When we're looking at case 2 of the quadratic, we will have to apply a different technique. But why do we use this technique for case 1? Now, remember that when we expand brackets, we multiply them out, we get x times x, we get x squared. We get x squared. And then now x times 3, we get 3x. So we get 3x. And then now x, 2 times x, we get 2x. And then 2 times 3, we get 6. Now, when we reach this stage, what we generally do is add the like terms in the middle. And then we would get 5x plus 6. So you notice here, if you multiply out the brackets or the factors that you get, you should get back what you started off with in the question. So what really happened here is that this expression is the product of these two factors. When you multiply out these factors, it gets a product of x squared plus 5x plus 6. That means when you factorize this, you're getting it back to factors. So you're breaking up back the factors back into products. So by reversing the process, so the process is reversed when we try to go back from here to a 4-term expression, and then from the 4-term expression, we factorize by grouping to get back the 2 factors. So we are really reversing the process. So that is the reason why this technique always look for 2 factors that multiply to give it the last term 6. When you add them, you get the middle term 5. So that's kind of the technique that we use to reverse quadratic. All right, any question, guys? Is it straightforward what we just did? So find 2 factors of 6. We could try 6 and 1, but we see that 6 plus 1 would not give you 5. Instead, it will give you 7. So those two factors wouldn't work. So we then try some other factor. So the factors that seem to work would be 3 times 2. 3 times 2 give you 6, and 3 plus 2 would give you 5. And so we now replace the middle term with this sum of 2x plus 3x. And then now we have a 4-term expression. Now we can factorize by grouping. We pick out the common factor of each pair. Then we pick out the bracketed expressions as the common factor. Then we group what remain outside in the second bracket. All right. Everybody see the process? Now here we have another example doing the same thing. So now, can somebody tell me 2 factors that you can use to multiply to get 12? When you add them, you get 7.
3 and 4.
3 and 4. So what are we going to do now that we find the 3 and 4? Ms. Travia? What is the next step? So we identify the 2 factors. Factors would be 2 and 6. Those can't work. 3 and 4, yes, those are the factors that we're looking for. So we say 3 plus 4 gives you 7. What is the next step now, Miss?
So plug them into the equation.
You're going to?
Sir, plug them into the equation, meaning fill out the equation with the numbers.
All right, so plugging in is another word that you want to use for substitute. All right, so you're really replacing the 5, not the 5x, you're replacing the 7x with these 2 numbers, but now you have to put x beside them in order for them to become 7x. All right, because when you put x beside them, you see that 3x plus 4x gives you 7x. So we're going to take out that 7x from the original expression. Then we replace that 7x with 3x plus 4x. Now we have for a 4-term expression. Now what we do next now is to factorize the 4-term expression by grouping. So you look at each pair. The first pair has a common factor. What is the common factor for the first pair?
X.
X. So it means that we can factor out x. So we choose x as our common factor. Open our bracket. So you open a bracket, x into x squared, leave x. And then we have 3x divided by x. X into 3x would leave 3. Close that bracket. Now this one now, what is common here? Now, what is common in terms of 4x and 12? So there's no obvious x that is common, but for the numbers, we look for a number that can go both into 4 and 12, but we're looking for the highest number that can divide 4 and 12. What would that be?
4. 4, sir.
4. So we pull out 4 as the common factor. And so we divide each term by 4. 4x divided by 4 give you x. And 12 divided by 4 give you what? 3.
3.
Right. So at all times, you want to ensure that these 2 bracketed expressions are the same. So you must have the same expression in both brackets. Once you have that, now you treat the bracketed expression as your common factor. You pull that out. And then now you divide each of the term by your bracketed expression. So you have, this thing is so crazy. So you have x plus 3. And you divide each of these, x times x plus 3 divided by x plus 3. We put now, the x plus 3 cancel, we have x remaining in the brackets. Then keep your plus sign. Then x plus 3 divided by 4, bracket x plus 3, the x plus 3 cancel even 4. Close your brackets, and then those would be your factors. Any question about that? Is that clear to everyone? Let me see your hands, guys. All right, so all right, so everybody is good with that. All right, moving along. Now, we've gone through, we did the factorization, we get our factors, x plus 3 times x plus 4. All right, now, let us see how well you will be able to apply what you just learned to this question. Let us see if you can wrap your head around this one. So if you can find two factors, when you multiply them, you get -3. When you add them, you get -2. What